Hello everybody, welcome back to another video with Mr. Coder, and in this video I'm going to show you how to do D function, question G from Codeforces Round 952 Division 4. So let D of n represent the sum of digits of n. For how many integers n, where 10 to the L is less than or equal to n, which is less than 10 to the R, satisfy D of k times n is equal to k times D of n. Output the answer modulo 10 to the 9th plus 7. So you have t-test cases and you have L, R, and K. L is less than R, which is less than or equal to 10 to the 9th, and K is less than or equal to 10 to the 9th, and greater than or equal to 1. So since the key thing to realize is that it's 10 to the power of the L and 10 to the power of R. So like the 10 to the power of 0 is 1. So that's a key thing to notice. And so for the first case, there's 1. L is 0, which means 10 to the L is 1. 10 to the 1, 10 to the first is 10. So then there would be the numbers 1 through 9 inclusive, or 1 through 10 exclusive. And then the two solutions that work are 1 and 2 values of n that work are 1 and 2. So the answer is 2. And they work because the sum of the digits of 1 is 1. And then if you multiply that by 4, it's 4. And the sum of the digits of 4 times 1 is 4. Sum of the digits of 4 is 4, so it's the same. And that also works for 2. So yeah, that also works for 2. So if we take a look at the next example, there's 3 solutions that work, ranging from 1 to 100, not including the 100. So it's exclusive on the 100 end. So the ones that work are 1, 10, and 11. And a pattern that you may notice is that every time, like for example, if we take a look at the first test case again, 0, 1, 4, then why does 3 not work? Because if you have so if we go to the k times d of n, the d of n is 3, multiply that by k, which is 4, that's 12. And then d of k times n is d of 4 times 3, which is 12, which then is 3. The sum of the digits is 3. So that shows that if you carry your number, if it's not just like straight up, like on the same digit, then the number will change and it'll be different. So that's something to notice. And then after lots of using brute force to like notice patterns and stuff, then you'll notice that there actually is a pattern with these. So something to do first is to create this power function, and this is a log n power function that you can do and you have to code it so then you can keep modding, because there's a mod and you can have integer overflow if you try it without the mod, so you keep modding it every step. So, and you can just look this up if you need it, like during a contest. Like you can just look it up. And then so how I did the problem was I started with a number as 0, and then I looped through 1 through 9, I mean. And then you see if k times I is less than 10. If k times I is less than 10, then you update the number to be I. So then, because if k times I is less than 10, then that number wouldn't carry. So that number wouldn't carry. And then because you also have to include 0 as a number, so like for this power thing, you do the power of the number you get of I plus 1, and then you take that to the power of R, and then you subtract the power of the number plus 1, and then you do it to the power of L. And then since it's already modded, but then this subtraction could like interfere with the mod. It could not, because this subtraction could be negative because of the mod. So that's why you have to add mod to this result, and then you take it to modulus mod. So then it'll be the number positive modulus mod. And it's a good thing to note that it'll always be positive because you always have some positive amount of numbers of things. So that's why it has to be positive. And yeah, this is done with like lots of like stress testing, and like if you want to know how I solved it, I did it with a lot of stress testing and brute force. And of course brute force wouldn't work with like 10 to the power of 10 to the ninth amount of numbers. So, but then like I just did it for a smaller amount to notice patterns. So yeah, that's basically how you do D function, question G from Codeforces Round 952, Division 4. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.